guys, so this is lesson 3, as we're still in unit 7. We have approximately 2 more lessons. So this lesson 3, is on elimination, and what we've been doing so far, we've been graphically solving for solutions or intersections. We've been substituting expressions to solve for solutions or intersections. And at this point, what we're going to do is use the process of elimination, so we get rid of a variable. So what we want to get rid of here, we want to get rid of this part here, and we're going to rewrite it over here in the margin a little bit differently, because elimination, it's a method used to find the solution or the intersection of a system of equations. And basically the way we do it is we eliminate a variable. We recognize when we're using the process of elimination, we can easily recognize this when we, have variable terms on one side of the equal sign. Okay, so we only want variable terms on one side of the equal sign. Next, what we need to see, you need coefficients of one of those variables, of one of the variables, to be the same. So let's pause for a minute. Let's look at the first example problem that we're going to do. It says solve, we skip the steps, to solve x plus y equals 12 and x minus y equals 4 by elimination, check your solution. So we'll look at that equation. Do I have variable terms on one side of the equal sign? Yes, and the number is on the other for both equations. Now it says you need the coefficient of one of the variables to be the same, of both variables to be the same. And we can look at x and x, the coefficients are the same. If I rewrite, I have 1x plus 1y equals 12. 1x minus 1y equals 4. Okay, so coefficients are the same for x. There's a 1 in front. Coefficients are the same for y. There's a 1 in front. The additional thing that you need here, number 3, coefficients need to be opposites. Coefficients need to be opposites in order to proceed with the steps of elimination. So we have variables terms on the same side of the equal sign. We have coefficients that are the same. And the third thing we need is the coefficients to be opposites. And if you look, 1y and negative 1y fit that need. They fit that need. So what do we do next? We go to the steps. We start to follow the steps. We label the equations, number 1 and number 2. So this is number 1, this is number 2. We make sure both equations are in standard form. That's the x term plus the y term equals a number term. If not, put the x term and y term on the same side. We don't have to do that. Now, if there is a variable where the coefficient is the same but opposite, you go to step 4. So we can skip the rest of that part. So what we're going to do is eliminate the chosen variable by adding or subtracting its like terms. So we are going to draw a line underneath and start the process of elimination. Right? How do you start the process of elimination, you ask? Well, let me go back up a little bit. Well, we go from side to side and we combine like terms in columns. So I'm going to combine like terms first. So 1x plus 1x is 2x's. 1y minus 1y goes away, equals 12 plus 4, which is 16. I divide both sides by 2, and x equals 8. Okay, so I have the first part. Now I need to find y. So you could pick the first equation. We have 1x plus 1y equals 12. We know what x is. 1 times 8 plus, we can just write y equals 12. This is just 8. So I'm just going to subtract 1 times 8 and just put 8. 8 plus y. Solving for y, so I subtract 8 on both sides, and y equals 4. Then I'm just going to check my answer here. Does, when x and y map onto 8, 4, are these equations true? So we check the first one. We have x plus y equals 12. And we check the second, which is x minus y equals 4. Okay, so 8 plus 4 does equal 12. This is true. And 8 minus 4 does equal 4. So that's true. So my answer is, my solution is x comma y maps onto 8 comma 4. All right. Now, looking at the next one, we solve by elimination and check the solution. I'm just going to rewrite my problem here, my equations here. X minus 2y equals 4. So I'm going to label my equations. Now I'm going to look at the coefficients of my variable terms. And I'm also going to check, are x and y on both sides? Are they both, is x and y, or x and y, the variable terms, are they on one side of the equal sign for each equation? Yes, they are. Now I'm going to check for my coefficients. I have 1x and 1x. They're both positive. And then I have positive 2y and negative 2y. And there's my opposites. Those are all of the elements I need to start the process of elimination to eliminate y and only have x. So 1x plus 1x is 2x's. This goes away, equals 12. Divide both sides by 2. And x equals 6. Okay, so I have x equals 6. I just need y. So I'm just going to write x, start with the first equation. X plus 2y equals 8. Put in, substitute x in, and I have 6 plus 2y's equals 8. Subtract 6 on both sides. 2y's comes down, equals positive 2. Divide both sides by 2. Y equals 1. There's my answer. Now, I need to check to see if it's true that x comma y maps onto 6 comma 1. So are both of these equations true when my solution is 6 comma 1? So we check x plus 2y equals 8, and then we check x minus 2y equals 4. Okay, so x is 6 plus 2 times 1. Does this equal 8? Well, 6 plus 2, does it equal 8? 8 equals 8, so first one checks out. Next, 6 minus 2 times 1, does it equal 4? 6 minus 2 equals 4. 4 does equal 4, so it checks out as well. So when I write my answer, my solution is x comma y maps onto 6 comma 1. Okay, moving on. 3x plus y equals 16. 2x plus y equals 11. are my equations. We're solving by elimination. We're going to check the solution. So things we're checking for: 1, variables on one side only, one side, right? 2, coefficients are the same for a variable. 3, coefficients are opposites. Okay, so first, check off variables are on one side of the equation for both equations. Second, coefficients are the same for a variable. Check. Coefficients are opposites. No check. So how do we deal with that? So I'm going to rewrite my equations. 3x plus y equals 16. And there's a 1 in front there. And then I have 2x plus 1y equals 11. Now, if I need only for coefficients were the same, or 1y and 1y. If I need a coefficient to be negative, then I'm going to have to multiply by a negative on one of these equations. So I'm going to pick the bottom one to be negative. And when I do, I'm multiplying this whole equation by -1, and it's going to change the sign of each term inside of this equation. So what happens is I transition over. I get 3x plus 1y. I did nothing to this equation. It's fine as it is. All I need is that negative on the bottom. But in order to have the negative, what I do to one term, I have to do to every single term as a rule in algebra. So 2x is positive, it becomes negative 2x. 1y is positive, it becomes negative 1y. And I can feel that last need equals positive 11 becomes negative 11. And now I'm ready to start the process of eliminating. So 3x's minus 2x's equals 1x. 1y minus 1y goes away, equals 16 minus 11, which is 5. So essentially x equals 5. Easy stuff, guys. All right. I have x, I need y, so I'm going to say 3y's, go to my first equation and use it to find y. I'm sorry, it's 3x's plus 1y equals 16. And I say 3 parentheses 5 plus 1y equals 16, or 15 plus, we're going to say y equals 16. Subtract 15 on both sides, and y equals 1. So we're going to check, does x comma y actually map onto 5 comma 1 as I have deduced? Well, let's see. So we check both equations. We have 3x plus y equals 16, right, as one equation. The second equation is 2x plus y equals 11. 2x plus y equals 11. Is it true for both equations? So it's 3 times 5 plus 1 equals 16. Is 15 plus 1 equal to 16? Yes, this is true. Now, is 2 times 5 plus 1 equal to 11? Is 10 plus 1 equal to 11? Yes, this is true. So I can go and write my answer. My solution is, we're going to say my intersection is x comma y mapping onto 5 comma 1. What about the next one? Are both terms on the same side? No, they are not. You have y plus 2x's equals 17. That's fine. And then I have 5x equals 25 plus y. That's not fine. So I'm going to subtract y on both sides, to meet those requirements. Negative y comes down, plus 5x comes down, equals 25. And this goes away. Now I'm ready to start the process of elimination using the two equations. So here's my first equation, and here's my new second equation with both variables on one side of the equation. Now, I'm going to rewrite my equations as they are now. So I have y plus 2x equals 17. I have negative y plus 5x equals 25. Cancel the first y terms out, eliminate them. Have 7x equals 242. Divide both sides by 7. X equals 6. Now I need y. So I'm going to use my first equation. Y plus 2x equals 17. X is 6, so y plus 2 times 6 equals 17. That's y plus 12 equals 17. Subtract 12 on both sides. And y equals 5. And now I want to check, does x comma y map onto 6 comma 5? So I arrange my two equations. I have y plus 2x equals 17. I have 5x plus 5x equals 25 plus y over here. So y is 5 plus 2 parentheses 6 equals 17. 5 plus 12, does it equal 17? Well, 17 does equal 17. Now, for my second one, 5 times 6 equals 25 plus 5. I have 30 equals 25, equals 30. And so this checks out, so I can write my answer. My intersection is x comma y maps onto 6 comma 5. Okay? Next, last one. So variables are on both sides of the equation. I do not have coefficients that are the same. I do have a positive and a negative, so I'm going to focus on that y term in order to do this process next. So how do I get coefficients to be the same when I have opposites? I have variables on both sides. I have a 2 and I have a 3. What you can do is let's highlight those terms there. Let's highlight those two terms. So what we can do is multiply each equation this time by the coefficient in front, but we multiply opposite equations. This is a process where we're going to multiply coefficients by opposite equations. Listen to that language. Listen to that language. Multiply coefficients by opposite equations. So the coefficients I'm working with are -2 and 3. Technically, just 2 and 3. We don't need to change signs. We need to change numbers. We need to get the numbers to be the same. That's the goal. So 2 is coming down here. It's going to multiply down here. The whole equation is going to be multiplied by 2. 3, the whole equation is going to be multiplied by 3, or we're just essentially distributing 3 to each term, and you'll see that. We're distributing 2 to each term, and you'll see that. So how do I do that? Well, what did I make that look like? Well, let's write our equations. We have 5x minus 2y equals 20, and we're distributing 3 to each term inside. And we're going to do that over here. We draw a little arrow to indicate the transition that we're making, right? And then for 2, we're going to distribute it to each term in the bottom equation. So remember, we multiply coefficients by their opposite equation. All right, so let's do this. We're going to get some really big numbers here. So we want to be extra cautious, extra careful, and make sure that we're going to the graphing calculator that we need to. So I have 3 times 5x, or 3 times 5 is 15, and the x just slides along with it. So that's my first distribution. My second distribution is to the second term. 3 times negative 2 is negative 6, and the y carries over with it. And then we distribute that 3 to the third term. 3 times 20 is 60. Now, we've done that. We distributed that 3 to each term inside of that parentheses. Now we're going to go to the bottom and do the same type of process. 2 distributes to 2x first. So 2 times 2 is 4, and the x follows along with it. 2 times 3y, so 2 times 3 is positive 6, and the y carries along with it. I bring my equal sign over. Then 2 times 27 equals 54. Now we go through the process of elimination. So 15x's plus 14x's is 19x's. 6y's go away equals 114. In order to get rid of 19, I'm going to have to divide it on both sides. I do the opposite. X equals, do I know what it is? Probably so, but you'll never know because I'm going to the graphing calculator like a boss. 114 divided by 19 equals 6. There we go. So this equals 6. X equals 6. Now I just need y. So I'm going to revert back to my first equation. Write it down. 5x minus 2y equals 20. Right? 5 times 6 minus 2y equals 20. This becomes 30 minus 2y equals 20. Subtract 30 on both sides. And negative 2y comes down equals negative 10. Divide both sides by negative 2. And y equals positive 5. So I want to see, does xy map onto 6 comma 5 here? Got the same answer as last time. Let's make sure. Don't want to be tricky. Check both equations. 5x minus 2y equals 20. And 2x plus 3y equals 27. So 5 times 6 minus 2 times 5, does this equal 20? Well, does 30 minus 10 equal 20? Yes, it does. Next, does 2 times 6 plus 3 times 5 equals 27? Well, does 12 plus 15 equals 27? Yes, 27 equals 27, so it's true. So my final answer, my solution, I'm going to use SOL, abbreviate a little bit, is x comma y. We can be more savvy as we learn more about how to work in math. You can abbreviate. That's the whole goal. That's what you've been doing all along. Next are the word problems. So word problems, we're doing elimination typically, but some of these might not come out. So we're just writing the system. We're not solving the system. So we're going to first identify what we're talking about here. It says 2 records and 3 tapes cost $31. 3 records and 2 tapes cost $29. Find the cost of each record and each tape. So we're talking about records. We're talking about tapes. We want shorthand. This is what algebra allows us to do. It allows us to abbreviate things. So curly bracket. 2 records, so 2 R's, and means plus 3 tapes, so 3 T's equals $31. Reading the next one, 3 records, so 3 R's, plus 2 T's equals $29. We don't have to find the cost because we already know we're good. That doesn't tell us it don't tell us to do that in directions. Okay. Now, a group of students go to lunch If 2 have hamburgers and 5 have hot dogs, the bill will be $9. If 5 have hamburgers and 2 have hot dogs, the bill will be $12. What is the price of a hamburger? Don't have to answer that question, but we're talking about hamburgers and hot dogs. Okay, so we need variables here. So we have H and we have D. So we have 2 hamburgers plus 5 hot dogs equals $9. We have 5 hamburgers plus 2 hot dogs equals $12. And here's the system of equations. Lastly, the sum of 2 numbers. Their difference is 28. The sum of 2 numbers is 52. The difference of 2 numbers is 28. So what are my 2 numbers? We'll call them X and we'll call them Y. Okay, so this is a sum, and then X comma Y over here, this is a difference. It's 28. And the sum is negative 52. So when we write our system, we have X plus Y equals negative 52. X minus Y equals positive 28. Here's our answer. And this one's relatively easy to solve. As a challenge, I kind of challenge you to just go ahead and solve that. Moving on, you do have classwork today, and I kind of want to go through that with you. So to solve by elimination, you just noticed, are the variables on the same side? They are. Are they opposite? Yes. So all we do is draw our line. X minus X goes away. 2Y's plus 6Y's is 8Y's equals negative 24. Divide both sides by 8. Y equals negative 3. Now for X, I'm going to use the second equation. X plus 6Y equals negative 16. So X plus 6 times negative 3 equals negative 16. So X minus 18 equals negative 16. Add 18 to both sides, and X equals 2. My solution is X comma Y mapping onto 2 comma negative 3. Next, we'll kind of a review here. What is the solution to the system that is graphed? So we're just going to go put a bit dot here and kind of get our X. For our X comma Y here, we're mapping onto, let's go find X. 1, negative 2. So X is negative 2. And then up, 1, 2, 3. Y is 3. So negative 2 comma positive 3. Now, number 1 in the classwork, let's talk about perimeter. The perimeter of a rectangle is 86 inches. So perimeter is 86 inches. So all the way around, the length plus the width plus the length plus the width, that's the perimeter. So we have our first equation, the length plus the width plus the length plus the width equals 86 inches. Okay, so we're going to have to do a little work here. Now, the width equals 3 less than, let's be careful. So remember, we have to switch when we're talking about less than. So 3 less than the length, so L minus 3, right? So let's see what we got here. I got 2 different equations here. I have this equation and I have this equation. So let's go ahead and put our equations together. Let's move this picture out of the way here. Let's move the picture out of the way and move it up here. Let's move the picture over there. So here are my 2 equations. Okay, I'm going to move this over here. My first equation. I'm going to move that here. Actually, I'm going to erase that and move this right here. Right? So I'm going to fill in here. These are my 2 equations. So I'm going to simplify. First equation, 2 L's, so 2L plus 2 W's equals 86. And that looks like the perimeter formula in general, the one you can memorize. And then I have W equals L minus 3. So we could approach this problem to find the length and the width in two different ways. First, we're dealing with two variables. We could either use elimination, where we have variables on the same side, or we could use the process of substitution, where one of these is solved, one of these has a variable by itself. You have to decide which is the best way to approach the problem. One of them does have a variable by itself. One of these equations does, and we want to use that method of substitution. So we're going to substitute L minus 3 into L, into that equation. So 2 parentheses, sorry, not that equation. We're going to substitute this into W. We're going to substitute it into W. So 2 L's plus 2 parentheses L minus 3 equals 86. Simplifying, I get 2 L's plus 2 L's of distributing minus 2 times 3 is negative 6 equals 86. Combine like terms, I have 4 L's minus 6 equals 86. Add 6 to both sides, and 4 L's equals 92. Divide both sides by 4. I get L equals 26. I think we're talking about inches. Yes. All right. Now I need the width. The width equals L minus 3, or equals 26 minus 3. This equals 23 inches. So when I write my answer, width WL maps onto 23 inches and 26 inches. And this ensures that you know what W is, you know what L is. Next. All right. So it says 3 Cokes and 1 box of popcorn costs $4.60. 2 Cokes and 2 popcorns cost $6. So we have Cokes, we'll call them C's. So 3 C's plus one popcorn equals $4.60. Next we have 2 Cokes plus 2 popcorns equals $6. All right, so I'm going to write my equations down here. 3C plus 1P equals $4.60. 2 C's plus 2 P's equals $6. So we need to pick a variable. We need to pick a method for solving this. I say elimination because variables are on both sides. We could use substitution, but it means work that we don't really want to do. So in order to make this work for elimination, I need to pick one of these variables. I'm going to pick the P's. And obviously I need to make the coefficients of P, both P's, the same. So I have 1 and 2. That means I'm going to multiply by opposite numbers. And then I need to make one of these P's negative. So I need to multiply by a negative as well. So what I could do is multiply by -2 on the top, okay? And I don't have to worry about multiplying by anything except 1 on the bottom. When I transition over to my new equations, I have -2 times 3 is -6 C's. -2 times +1 is -2 P's equals -2 times 460. Let's go to the graphing calculator here. We don't want to play games. We want to be accurate. So 460 times -2 equals -920. -920. It's -920. So $9.26. On the bottom, 1 times 2 C's is 2 C's. 1 times 2p's is positive 2p's. 1 times $6 is $6. Now I'm going through the process of elimination. Negative 6 plus 2c's is negative 4c's. This goes away, equals negative 320. Divide both sides by negative 4. C equals 80 cents. 80 cents. Now I can go ahead and figure out how much, I know how much Cokes are, how much are popcorns, how much is popcorn. So 3C's, use my original equation, 3C's 1P equals 460. I know C equals 3 times 0.80 plus 1P equals 460. I'm going to make that 1P just a P. I get 240 plus P equals $4.60. Subtract both sides by $2.40. And P comes down equals $2.20. So when I write my answer, I'm going to write it in terms of C and P. So C comma P maps onto 80 cents for Cokes. So I'm going to put Cokes, 80-cent Cokes, and $2.20 popcorns. Some expensive popcorn. So that's the classwork for this particular lesson. We have on the back number 3, number 4, and we'll be done. Okay, so it says the sum of two numbers. We have sum of two numbers, so we need two numbers. We need x and y, and their sum equals 90. The difference of those two numbers is 18. It has to be in the same order. So here it looks like we're going to be using the process of elimination because their variables are on the same side, coefficients are the same, and they're opposites, and we just eliminate. So 1x plus 1x is 2x's. This goes away, equals 108. Divide both sides by 2. X equals 54. Now I need to solve for y, so x plus y equals 90. I have 54 plus y equals 90. Subtract both sides by 54. And y equals 36. All right, so when I write my answer, x comma y maps onto 54 x's and 36 y's. Next one, let's read the problem. We have the sum of two numbers is 88. Their difference is 16. Our two numbers are x and y, so x plus y equals 88. And then x minus y equals 16. I come to my curly bracket, write my first equation, write my second equation, and we're going to be using the process of elimination. Once again, we could use something else, but why do that when we know what we're going to do, right? So eliminate 2x, x plus x is 2x, eliminate y, equals 4, 1, 8 plus 1 is 9, plus 1 more is 104. Divide both sides by 2. I get x equals 52. That's x. And then I need to check for y. So I have x plus y equals 88. 52 plus y equals 88. Subtract both sides by 52. Y equals 36. So when I write my answer, x comma y maps onto 52 comma 36. And there you go. So for homework, what do you have to do? Homework, you have this to do, and make sure you're writing the intersection. Also make sure you're writing the number of solutions. Next, after this, we have word problems, and then we have solving linear systems. You guys are doing so well. So have a good day.